Hi class. In this lecture here, what we want to now talk about is set operations. And there's going to be a couple main definitions. We're going to talk about something called the complement, the union, and the intersection of sets. And I'm going to illustrate it with Venn diagrams and just working a ton of examples throughout this lecture. So hopefully by the end of this lecture, going through all the examples, you'll have a really good understanding of set operations. Okay, so we'll start with one of the easier ones. Okay, and it's what's called the complement of a set. Okay, the complement of set A, symbolized A with a little like dash, little prime here. It's also shown as A with a superscript C as well. But so whenever you see that A prime or AC, it represents the complement. And all this is the set of all elements in the universal set that are not in set A. So just think about it as like everything not in A. If it's in A, it's not in A complement. So this idea can be expressed in set builder notation as the following. A prime or A complement, A superscript C, is equal to the set of all elements X, such that X is an element of the universal set and X is not an element of A. Okay, so the shaded region here, like if you look here in this using Venn diagrams here, this blue shaded region represents the complement of set A. So if here's set A, anything outside of set A, okay, is the complement. So anything outside set A is A complement or A prime. Okay, referred to as the same thing here. All right, so let's do some examples here. So let's let you. I'm gonna add another one to this page too. Okay, so let's let the universal set be the numbers 1 through 9, as you can see over here, and let's let set A, okay, be equal to this numbers 1, 3, 4, 7. Okay, find A prime. So that means A prime, which is the same thing as A complement. Okay, that's just everything that's left over. So what's outside of A? It's the numbers 2, 5, 6, 8, and 9. All right, let me even just do another example here. Suppose you have this. I'm going to draw. Forgive this is a little bit of a crazy drawing here, a little bit of a rough drawing, I mean. Here's set A, and here's set B. So there's some overlap, okay? So it's 1, 2, and the overlap is 3, 4, 5, and 6. Okay? So look, what is set A? Okay? A is equal to 1, 2, and 3, right? Even though there's the overlap here. So then what is A complement here? Well, it's everything that's left over. So 1, 2, 3 is in A. Okay, so what's left over? Well, 4, 5, and 6. And you can see, you can also do it this way. What is set B? Set B is the numbers 3, 4, 5. So then what is B complement? Well, what's left over? Well, it's 1, 2, and 6. So 3, 4, and 5 were in B, and 1, 2, and 6 is left over, so that's its complement. All right, so think about the opposite, if that helps. Okay, the complement is everything else, the opposite. All right, now let's talk about what's called the intersection. Okay, the intersection of set. The intersections of set A and B, written as A, and this right here, this notation means intersection. A intersection B is the set of elements common to both sets A and B. So it's the elements in both that occur in both. All right, elements that occur in both sets. Think about it as what elements are in common. right, so this definition can be expressed in set builder notation as the following. A intersect B is equal to the set of elements X, such that X is an element of A and X is an element of B. Okay, so the intersection, when you look at this Venn diagram, the intersection is this shaded part, okay? Intersection is the overlapping parts. Okay. So if you look here, all right, just looking at this Venn diagram here, set A is A, B, C, D. Set B is D and E. And look, if you could just, just by inspection, just by looking at it, they both have the element D in common. So A intersection B, it's just that common element D. It's that overlapping part here. All right, let's do some more examples. All right, so for each of the following, let's find their intersections. Okay, so I'm taking the set 7, 8, 9, 10, 11, and intersecting it with 6, 8, 10, and 12. Well, look, so intersection, what do they have in common? Do you see how they both have an 8 and 10? So their intersection is just the set of the numbers 8 and 10. I don't know, let's see here. 1, 3, 5, 7, and 9. 2, 4, 6, and 8. Do you notice how they have no common elements here? So what that means is their intersection here, what does it produce? It produces the empty set. They have no common elements. What's also really interesting, if you take the set 1, 3, 5, 7, 9 and intersect it with the empty set, well, what does this set have in common with nothing? Well, obviously it has nothing in common with it. So it itself is the empty set. So whenever you intersect something with the empty set, you get the empty set. Okay. All right, so again, intersection. Just look what they have in common. So find the common elements. All right, now let's talk about something called the union. So the union of sets A and B, written as A, and this symbol here means union, A union B, is the set of elements that are members of set A or set B or both sets. Think of it as like the example I like to describe is like, when I got married to my wife, we formed a union, and she had all her stuff in set A, and I had all my stuff in set B, and then we brought it into a house. We brought it all together. So think of it as a combining. Okay. So this definition can be expressed as the following: A union B is equal to the set of elements X, such that X is an element of A, or it's an element of B. So look, going back to this example here, set A is the elements A, B, C, D. Set B is D and E. D and E. And when we want to have A union B, so basically it gets pushed together. So you notice how they both have a D. You're not going to write D twice. Okay, so it's going to be A, B, C, D. I already have the D, E. Wrote this as a capital here, an accident. But yeah, that's a good. So just think about it as you're pushing the sets together. All right, and if they both have the element D, you're only going to write the element 1. Okay. So the union, think of it as combining the sets. And you just remember, only write common elements once. Okay. Let's find some examples here. All right, so for each of the following here, basically it's the same look. All right. So we want to take the set 7, 8, 9, 10, 11 and union it with 6, 8, 10, 12. Well, look, you're going to combine them. So there's a 6, 7. They both have an 8, so I'm only going to write 1, 8. There's a 9. They have a 10 in common, so I'm only going to write it once. There's an 11, and then there's a 12. So look, I just combined the sets together. Same thing over here, which was interesting. When we found the intersection, it was the null set, but when you union these, you go 1, 2, 3, 4, 5, 6, 7, 8, 9. It's pushing them all together. And then here, when you take the set 1, 3, 5, 7, 9 and union it with the empty set, well, when you push these two together, you're taking this set and unioning it with nothing, so you get that. Okay, so intersection, what do they have in common? The union, you're think of it, I hate to say this, but you think about it like you're adding the two sets together. You're putting them together. Okay. Just a quick thing what we saw with the empty set. A intersection in empty set is always an empty set, and A union with the empty set is just the set A. So like here, if this is set A, you just got set A. All right, let's do an example now where or talk about how you do like much harder problems. All right, and this is performing set operations that involve a lot of steps to it, okay, or more than one intersection or more than one union. Okay, so some problems involve more than one set operations. These set notation specifies the set notation specifies the order in which we perform these operations. So always go left to right, but always begin by performing any operations in parentheses. Okay, so work left to right, but start with parentheses here. All right, so here's the problem, okay? So we've got the universal set, okay, and we've got three sets here, actually, okay? So we've got universal set is the numbers 1 to 10. Set A is 1, 3, 7, and 9. Set B is 3, 7, 8, and 10. Set C is 1, 2, 3, 4, 5. Okay. So look here, first thing it says is find A union B, and then this out here says take its complement after. So A union B and then complement it, okay? A union B and then complement. So let's start up here. Let's first find what A union B is. So I'm going to take A and B and push them together. So it looks like I would get 1, 3, 7, 8, 9, 10. 1, 3, 7, 8, 9, and 10. And then when I take the complement of this, okay, the complement is everything that's in the universal set that's not in here. Well, so it would be, what's in the universal set that's not in A union B here? Well, it would be 2. 3 is over in here. So 4, 5, 6. And then look, it has 7, 8, 9, 10. So it would just be 2, 4, 5, and 6, okay? So, find out what's inside the parentheses first, and then here what I did was, and then I took the complement. So there was a lot going on for that one. All right, so now this says A complement intersection with B complement. So what I have to do here is I have to find the complements first. All right, so let's figure out what A complement is. So it looks like it would be 2, 4, 5, 6, not 7, but 8, and 10, and then B complement, well, that looks like it would be 1, 2, not 3, but 4, 5, 6, and then not 7, not 8, but 9. So when you look, you can say, okay, all right, what elements does this have? Do these two sets have in common? It looks like it's 2, 4, 5, and 6. Wow, look at that. And yes, you were supposed to get the same thing here. What's really interesting is if you distribute the complement, like you think about it in algebra, it would flip this from a union to an intersection. All right, now let's do some problems that involve, you know, multiple operations here. All right, so what we have to first find, okay, what we have to first find here is B complement intersection with C. Okay, so B complement intersection with C. Well, here's B complement and here's C. Okay, so what do they have in common? Looks like they both have a 1, 2, a 4, and a 5 in common. All right, so that's B complement intersection with C. All right, now I have to, this is where it's crazy, now I have to union it with A complement. Well, here's A complement. It's 2, 4, 5, 6, 8, and 10. Well, when you union them, right, you're pushing them together, okay? So A complement starts with a 2, but I also have a 1 over here, so it's 1, 2, and then they both have a 4, they both have a 5, and then it's the rest of what's in A complement, which is 6, 8, and 10. All right, last one here. A intersection, but then in parentheses, B union C. So let's find up here what B union C is. So I'm going to take B and C, I'm going to push them together. So I'd get 1, 2, 3, 4, 5, 7, 8, and 10. 1, 2, 3, 4, 5, 7, 8, and 10. And then I'd intersect that with A. So well, what do they have in common? It looks like they have a 1, 3, and 7 in common, not a 9. Okay, so just a 1, 3, and a 7. So again, here what you're doing is you're just going step by step. You're figuring out what's inside parentheses first, and then you're finding the other set operation here. All right, class, you'll get a chance to practice this obviously on assignments, and as always, if you have any questions, I am here to help.